So time and time zones. Okay, so the second one is a lab activity. This is the one that's optional. It's worth 10 whole points. So this is, it'll ask you to make a copy. I probably have about 26 of them. Let's see how many I have. Let's see how good I've been at cleaning out my copies. Nope, it just says copy. Cool. All right, so this has a reading, and then there's some interactive stuff, and then there are questions, and then there's a video, and then some questions, and then a video, and some questions, and a video. So it explains how to do each of these things. So it says, let's say that you're located at the noon meridian and your friend's house is 1 degree longitude east of your location. What is the solar time at your friend's location? It then says, recall that 1 degree is worth 4 minutes of solar time. Also recall that locations to the east are later in time, so your friend's house would be 12:04. So what this is talking about is where the sun is located and something called a subsolar point. Is this really? I feel like I'm in the wrong. Oh, no. Oh my gosh, I'm sorry. This is the right activity. I'm just thinking of which class I'm in, and I'm like, why are we doing this already? Because you guys are 4 weeks ahead of everybody else. Okay, love you, mean it. Okay, so what would the solar time be if 1 degree longitude to the west? So if we add when we go to the east, we're going to subtract when we go to the west. So you're just going to say something like 12 o'clock minus, 4 minutes equals 11. Gonna go with 56. Yeah, there we go. I should probably put in minus 4 minutes because it's to the west. It would be 11:56. There, I've shown my work. What would the solar time be if you were 8 degrees longitude to the east? So if we go east, is it earlier or later? Later. And for each degree of longitude, it's 4 minutes. So that would be equal to 8 times 4 equals 8 and 8 is 16 times 2 is 32 minutes plus noon equals 12:32 p.m. I wanted to be sophisticated. I could say a.m. All right. So then it starts doing the same thing here. I would definitely use this little graphic down here. It's really helpful in my opinion. That's why it's included. So what would be the solar time at each of the following different locations at the same moment in time? So take assume you live at 40 degrees and it was noon. What would the solar time at each of these different locations be at the same moment in time? So let's see. I live at 40 degrees west. They live at 60 degrees west. That's going to put them further west. So it's going to be 20 degrees, alt 0186 west, right? And it was noon, 20 degrees west. West is going to be minus time. Convert the degrees into minutes and hours and then solve. So that's going to be 20 times 4. That's 80 minutes, which is 1 hour and 20 minutes. And I'm going to say before noon, just to remind myself that I have to subtract the time. And so 1 hour and 20 minutes before noon would be 10:40, because that would be 11 plus an hour is 12. Yes, so 10:40 a.m. at this location. Now, just to reiterate, re-emphasize, recongeal. No, that's not the word I'm looking for. I'll just say reiterate. These activities are important because you're going to be doing similar mathy type things in your quiz. All right, so I'm gonna say that's all I have for this week. Oops. And I hope you all have a nice week. Take a look at the rest of the video because it talks about lots of different stuff. There's a lot of vocab in there. That's what it is. It's in my lecture class on solar time and subsolar point and all that stuff. Those are kind of important. So if you're not taking me for lecture, then you may not have had exposure to this, and therefore when I asked you in the lab, which I should have went over today, but I didn't, I went over the models instead. So take a look at the video, and if you still have any questions, shoot me an email and I'll get you some more help so that you can be successful on the lab activity. But other than that, I hope you all have a nice week.